Morning students, I am Manikant Mishra, Modern English School, New Area. So yesterday we are discussing about the electron configuration. It means distribution of electron in various cells. How many electrons can be put in each cell? That is decided by 2n square that was given by Bohr and Bury, where n represents the number of cells. That this part we have already discussed. Like in K cell will have maximum number of electrons. In K cell will have the maximum number of electrons. To L cell will have maximum of 8, M cell will have 18, N cell have maximum of 32. So these electronic configuration yesterday we have already discussed based on 2n square when n represents the number of cells. My dear students, as you know that there are 118 elements. Out of 118 elements, 6 elements usually do not take part in a chemical reaction. They are called inert. Why they are called inert? And what is the cause of their inert? So first, as I say, why it is called inert? Because these 6 elements do not take part in a chemical reaction. They do not form bond with other element. They exist as in a monovalent, in a monoatomic state. Like we are writing H2, H2, because H do not exist in the nature because of its reactive nature. Similarly, O we do not write O2, N2, they do not exist in atomic state. These are the atomic state. They do not exist in the nature in their atomic state, rather they exist in their molecular form H2, O2, N2. This is due to its reactive nature. But if you talk about the helium, it exists in the nature in a atomic state. Neon, it exists in the nature in their atomic state. Argon exists in the nature in their atomic state. Now, here you see these are diatomic, but it is a monoatomic. So what I am trying to make you understand that helium, neon, argon, other elements are krypton, xenon and radon. They are inert nature. They do not take part in a chemical reaction. That's why they are called inert. Now what is the cause of their inert behavior? Why these 6 elements helium, neon, argon, krypton, xenon and radon are inert nature? So it was observed that in their outermost cell, other than helium, there is a 8 electron. There is a 8 electron. So it means having 8 electron is the cause of their inert behavior. Having 8 electron is the cause of their inert behavior. What is the cause of inert behavior? Why these 6 elements do not take part in a chemical reaction? So other than helium, all have 8 electrons in their valence shell or in their outermost shell. Outermost shell is known as valence shell. Let me write the electronic configuration one by one. Like if you talk about the hydrogen, hydrogen has atomic number 1. What is the atomic number? The number of proton presence. The number of proton presence in the nucleus. The number of proton presence in the nucleus of an atom is called atomic number. And number of proton is also equal to the number of electron. Number of proton is equal to the number of electron. So here hydrogen has atomic number 1. It means hydrogen has 1 electron. So now if you distribute electron, the very first shell, that is a K, that will have 1 electron. If you talk about the helium, I am writing this side. Helium has 2, atomic number is 2. So it means the number of electrons present in the helium is 2. That is in K cell. And you also keep in mind, K cell has maximum capacity to accommodate 2 electrons. Here you see K cell can accommodate only 2 electrons. Now, suppose we talk about the oxygen. Oxygen has atomic number 8. So, electronic configuration Kl2, 6. 2 plus 6, 8. 2 plus 6, 8. So first 2 electron and the remaining electron, if it is less than 8, we will put in L cell. If it is more than, then we will go for next cell. I will take example. Similarly, if you talk about the nitrogen, 7, 2, 5. Suppose we take sodium, 11, 2, 8, 1. So M cell also will have now. And here you see the neon. Neon atomic number is 10. 2, 8. Argon 18, 2, 8, 8. M cell. So you see that helium has only 1 cell, K cell, that is also filled. Here K cell is called valence cell in the case of helium. K cell is the outermost cell. Outermost cell is called valence cell. Neon, L cell is the outermost cell or valence cell. Argon has M cell is the outermost cell. Here also you see that hydrogen has K cell is the valence cell, oxygen L cell, and nitrogen L cell, sodium M cell. So if you compare the electronic configuration from this element to this element, then we found that helium, other than helium, this too has 8 electrons, but here you see none of the element has a stable electronic configuration. These are called stable electronic configuration. These are called stable electronic configuration. Before I move on again to this same topic, let me tell you one more thing, that yesterday we have talked about K cell can accommodate maximum of 2 electron, L cell maximum of 8 electron, M cell maximum of 18 electron, and N cell 32. But there is a condition that if M cell becomes the outermost cell, M cannot accommodate more than 8 electron because of octet theory. This is called octet. Why it is a? Because there is a dream for all the elements to achieve 8 electron in their outermost shell, because having 8 electron is considered to be the most stable arrangement. So all other elements try to copy the electronic configuration of inert gas elements. Tries to achieve the electronic configuration of either of duplet, it means 2 electron in their outermost shell, or 8 electron in their outermost shell. So if M cell is the outermost shell, M cannot accommodate more than 8 electron. As for example, if you talk like a potassium atomic number 19. So if you write the electronic configuration in K cell 2, L cell 8, M cell 8, N cell 1. You see, we cannot write 9 here because outermost cell cannot accommodate more than 8 electron. That's why one new cell has generated N. Again, if you write calcium 20, so 2, 8, 8, 2. Is it clear? So M cell, if M cell is the outermost cell, M cannot accommodate more than 8 electrons. Now, as I said, again come to here. So all the other elements, tries to achieve either of duplet or of the octet, and this is done by, like here, hydrogen has 1 electron. Hydrogen has a dream to achieve the electronic configuration like of helium. Oxygen has 6 electrons in its outermost shell, so oxygen has a dream to achieve the electronic configuration like of neon. Similarly, nitrogen has 2, 5, so it has also dreamed to achieve the electronic configuration like of 2, 8. Sodium has 2, 8, 1. Sodium has also as a dream to achieve electronic configuration like of neon. Potassium has 2, 8, 8, 1. It has a dream to achieve the electronic configuration like of argon. Calcium 2, 8, 8, 2. It has a dream to achieve electronic configuration like of argon. So these elements has a dream to achieve either of duplet or of the octet. This is done by either losing, gaining, or by sharing. How they achieve the stable electronic configuration of nearest noble gas configuration? Either by losing, gaining, or sharing. The achievement of stable electronic configuration by these elements, hydrogen, oxygen, nitrogen, sodium, potassium, calcium, all these elements can achieve in their outermost shell 8 electron either by losing or by gaining or by sharing. Like here you see, sodium has a 1 electron in their outermost shell. So sodium prefers to lose 1 electron in order to get electronic configuration like of neon. So sodium achieve a stable electronic configuration by losing 1 electron. Similarly, if you talk about the chlorine 17, 2, 8, 7, KLM, you see that chlorine has 7 electrons in their outermost shell. So chlorine not prefer to lose 7 electron, rather chlorine prefers to gain 1 electron. Just keep it in mind what I said. Sodium has 1 electron in their outermost shell. Sodium tries to tries to achieve the electronic configuration like of neon. For it, sodium is losing 1 electron. Chlorine has 7 electrons in their outermost shell, so it prefers to gain 1 electron. Sodium prefers to gain 1 electron because it has 7 electrons in their outermost shell, and chlorine has a dream to achieve the electronic configuration like of argon, that is a 288. Similarly, hydrogen has 1 electron. Hydrogen has 1 electron. So hydrogen tries to share with another hydrogen or with some other element also. Each has 1 electron in their outermost shell. So both are sharing. You see, this hydrogen has now 2 electrons like of helium. This way of achievement is called sharing. So, my dear students, achievement of 8 electrons in their outermost shell takes place, as I said, either by losing, gaining or sharing. Now, how many electrons can lose? How many electrons can gain? How many electrons can share? That is this. That the number of electrons by an atom can lose, can gain or share. That is this side. That is called valency. That is called valency. In other way, we say the combining capacity of an element. Combining capacity of an element is called valency. Combining capacity of an element is called valency. As for example, sodium can lose 1 electron. Sodium can lose 1 electron. So sodium has valency 1. On the other hand, chlorine can gain 1 electron. So chlorine has also valency 1. Sodium can lose 1 electron. So sodium has valency plus 1, and chlorine can gain 1 electron, so its valency is minus 1. So for sometimes you can say that sodium has plus 1, chlorine has minus 1 valency. Now if I say potassium also can lose 1 electron. Potassium can lose 1 electron, so its valency is also plus 1. Oxygen has 6 electrons in their outermost shell. Oxygen need 2 more electrons in order to achieve electronic configuration like of neon. So oxygen has valency minus 2 or 2. Oxygen has valency 2. 8 minus 6. 8 minus 6. Because oxygen prefers to gain electron rather than lose 6 electron. Similarly, nitrogen cannot lose 5 electron, rather prefer to gain 3 electron. So 8 minus 5 valency is 3. Nitrogen has valency 3. Similarly, calcium has 2 electron in their valence shell. So calcium prefers to lose electron in order to achieve the electronic configuration like of argon. So calcium has valency plus 2. So combining capacity of an element is called valency. The number of electrons present in their outermost shell. The number of electrons present in their outermost shell decide the valency. Like if the number of valence electron is 1, valency is 1. If the number of valence electron 2, valency is 2. If the number of valence electron 3, valency is 3. Number of valence electron 4, valency is 4. If the number of valence electron 5, 8 minus 5, 3. If the number of valence electron 6, 8 minus 6, valency is 2. If the valence electron 7, the valency is 8 minus 7, 1. If the valence electron is 8, the valency is 0. So it is also called zero valent element. Zero valent element. because its combining capacity is 0. Combining capacity is 0. So, see the video. Though these days you are not watching the video, maybe busy in making the fair notebook, I think so. So, it's alright, maybe that next day from Monday onwards we will meet physically in the classroom. Till then, thank you, have a nice day.